Hey, hello everyone. Today we are going to solve this daily challenge from LeetCode, maximum number of events that can be attended, part 2. So it is marked hard level. Here we are given an array of events where each element is itself an array consisting of the start day of the event, end day of the event, and the value that we get on attending that event. So here we need to return the maximum sum of the values that we can achieve by attending these events. So this question looks similar to a meeting room or trains departing a station. However, the limitation here is that we cannot attend events above certain value, that is k, and we also need to take care that the events are not overlapping. So what we can do is we can start by sorting the events based on their starting time. So first we will sort them in that manner: events dot begin, events dot end. Now our next task can be that we can either attend an event or not attend an event. So this can be done by making use of a recursive function, and yes, so we need to write a helper function for that, which will return me the maximum amount of like the maximum value that we can get when we are at that event. So I'll write this helper function that will take events as its argument, and then we will need the index and also the number of events remaining. So this will be our answer as well, whatever the value we are getting back. So let me pass these variables. We'll start with the first event that is in the sorted list, and the original size would be the number of events that we can attend would be k. So once we are into this recursive function, we need a base condition. So that could be if I is greater than equal to events dot size. So if we are exceeded, we have exceeded the list, so we just return 0, so we do not get any value from that. Now what next? Yes, another condition that could be is if the number of events that we can attend has been breached, that is we have attended k events already, so then also we will return 0 because we cannot attend any more events. Now considering we do not attend the event, so what will happen? We will say not attend. We will just call this function again, and we'll pass the same variable events, and we'll go to the next element because we skipped this one, and since we did not attend this one, the k remains the same. Now what if we attend this event? So if we attend this event, the next event cannot be before the end time of this event. So we need to search through the array that the starting time of the next event should be greater than the end time of the current index. So for that we can make use of a for loop, but just to avoid TLE, we'll make use of binary search. So we will have a function called binary find next, and there we will pass the events array and the current index. So we need to find the position of the immediate next event that has starting time greater than the current end time. So it will also be an int, and int find next. Here we need this vectors and I. So our end time would be the current events end time, that is at the array index 1, and then to do a binary search we'll need a lower limit or left limit. So left is equal to I plus 1. We have to check for events after this current event, so I plus 1, and the upper limit would be the size of the array, so events dot size n minus 1 as well, because it should be n minus 1. Now we start okay, so we also need a default position to return if we do not find any events having start time greater than the current end time. Now we'll jump into the binary search where L should be less than or equal to R. Then we will have a mid variable, so L plus R, L plus R by 2. And now what we need to check, if events dot mid dot 0, so the start time of the mid element is greater than the end time of the current event, then what we can say that the position is equal to mid, and we can go to the left half of the binary search to see if there is an event starting before this event as well, so and satisfying our criteria. So we'll just make our upper limit to mid minus 1, and if the position if the start time of the mid position is not greater than the end time, then we'll just go to the right half by updating the left value to mid plus 1. Now we will just return position. So next what we can do is we get the position of the starting time of the next event having start time greater than the current end time, and it is stored at j. So we'll just say if we attend the function, then we will get the value of that event, so events 2, and also we will see what happens to the remaining k minus 1 events, and that we can attend starting from the position j that we just found, and the number of events remaining are k minus 1. So this is it. Now, so there were two cases whether we attend them or not attend them, so we will return the maximum value whichever like between these two, attending and not attending these the current event. Now one thing we also forgot is that the position was defaulted to minus 1. What if there is no event that starts after the end time? So in that case the position returned would be minus 1. So when this get calls, we need to take care of that as well here by saying if I is equal to minus 1, then also the value will get is 0. So yes, we handled that case as well. So we can now run the function. Okay, now the next thing is that this question can give TLE, because we are calling this helper functions again and again, so we need to memorize some things. So we need dynamic programming memorization, and for that we will create a dp vector. So vector and its size would be, so it's dp, and then the size would be events dot size, and it should be a 2D vector. So because at every event we also need to take care how many events were remaining to attend, so what was the value of k when that index was called. So therefore I am making it a 2D array. So we'll just declare this first, vector int, and its length should be k plus 1, because we are considering one indexed numbers for k, so it should be k plus 1, and default value should be minus 1. And let me just pass this value in dp as well, in helper functions whenever we call them, dp. Next we'll have to write a test case. If the value of the current call is not equal to minus 1, we'll return the value stored, and if it was not stored, we will store it while returning, so that we do not do the entire process again once it is called. Yes, so let's try this again. So here we did not declare the vector to be passed, vector int and dp. So it got accepted in the test cases. So yes, it is a satisfying solution, and was very easy to understand. Hope you liked it. See you tomorrow.